We have a power series and we want to use the alternating series test to make it converge. So if you look at those values, it might be easier just to kind of plug in. If we plug in 5, we just get 0, which doesn't make it alternate. If we plug in 2, it makes it -3/2, which is actually too big and it diverges, as well as 0 and -1 make it diverge. So 4 does make it alternate, and it does make it a convergent alternating series. So then that's our answer. All right, let's do the 1 on the left. So like a 1 over the natural log of n, we know it diverges, and it's pretty much, it's not as fast, but we are going to compare it to 1 over n. Okay. Oh, which of the following series conditionally converges? Okay, so conditionally, so we know we're looking at an alternating series, and we're looking at an alternating series that wouldn't converge unless it was alternating. And so if you look at 1 and 3, 1 over n and 1 over the square root of n would diverge, but since they're alternating, they do converge. So we call that conditionally convergent. Okay, which one converges for all real numbers x? Well, see this factorial down here? This is going to dominate. Here the exponential is going to dominate, exponential, factorial. This is actually never going to converge. And then this one's going to converge for all, because it doesn't matter what you make the exponential, since the factorial is in the denominator, it's going to dominate. Okay, that doesn't even converge, right? That sequence converges to 2, meaning the last term in the sequence is 2, but the series, meaning the sum, it doesn't converge. You just keep adding up 2 an infinite number of times. Both of these are geometric. You do have to be careful with this n equals to 1 to make sure you actually figure out what a and r are. And so in this case, a is 8/3 and r is -1/3. Here, a is 1 and r is 1/2, and both of those lead to a sum of 2 when you do a over 1 minus r. This stupid series is pretty much 1 over 2n, so we're going to compare it to the geometric series, and this is the geometric series. Again, 1 over 2n is the same thing as 1/2 to the n, because 1 to the n is just 1, so it's really just a geometric series with an r value of 2. Series converges. Factorial is going to dominate here, and since e is less than pi, this is less than 1, so it's a geometric series that converges. This does not. Over here, this is going to make it converge. Factorial is going to screw it up, and then this whole thing is pretty much 1 over n squared, right? It's an n over an n cubed. This is like a 1 over n squared. That's going to be good. That's oh, sorry. Lost my train of thought. That's a 1 over n squared. That's basically 1 over e to the n, or 1 over e to the n. And then this is a 1 over n. So this guy is not going to converge. So we're going to get 1 and 2. For a second there, I thought I got it wrong, but I was just going crazy. All right, I did that one. Okay, this one. This just keeps flipping back and forth between 1 and -1, 1 and -1. And you might think that goes to 0, but it just doesn't, right? The nth term test, look at the nth term of that, it just keeps flip-flopping between 1 and -1. That does not converge. This is basically like a 1 over an n, which is not good, but this is geometric with an r value of 1/3, so it converges. This is the only one. This is p series, right? And since there's an n up top, I need p to actually not just be greater than 1. I need p to be greater than 2, so that the whole thing has a power of greater than 1 over n. This one, this is garbage, 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 garbage. All of those are 1 over n. That one actually has a limit of 3, but this one is like a 1 over n squared, so it converges. Okay, here's our standard p series. We need p greater than 1/2, and then here we need this thing to be smaller than 1, which means we need p to be smaller than 2. So we have this interval where we converge. If you do the ratio test, you're going to get a 3 over x is going to be sandwiched between -1 and 1. But if we need this to be true, or really this is true, again, just think this through. 3 over x is less than 1 when x is greater than 3, and 3x is greater than -1 when x is less than -3. So this is the same as this. The absolute value of x greater than 3 is saying that it's sandwiched in between here. And again, we cannot let 3 or negative 3 actually be values, because then, we get some false. Conditionally convergent. Well, this is pretty much 1 over the square root of n, right? The 17 is stupid, and then square root of n over n is 1 over the square root of n, and it alternates, so it's an alternating series. Well, the alternating version of 1 over the square root of n converges, and it is conditional. All right, these kind of dumb alternating series. This does keep decreasing, and it goes to 0, check mark. This alternates, it constantly is decreasing, and it goes to 0, check mark. This thing does not keep decreasing. Look, 0.4 to 2 to 0.3 to 1.3. I know maybe you think that eventually it's going to go to 0, but remember, it has to be alternating, and it has to keep going down every one of these terms, and it doesn't. It flip-flops here. So this is not going to work, and so it's only the first two. All right, this one's I don't know, it just kind of depends on how much you like this substitution here, but if we know sine of x is basically x when x goes to 0, then sine of 1 over n is pretty much 1 over n as n goes to infinity, right? As long as we're making the argument 0, we can make x 0 or we can make 1 over n 0 by letting n go to infinity. These are really saying the same thing. And so in this case, this at infinity is the same as this at infinity, and since this diverges, so does the other one. This is some geometric series. It's just like e over pi to the n. Be careful that there's an n equals to 1. So a is actually e over pi and r is e over pi. And so we'll do some algebra here and get the right answer. X is a real number. Okay, so this is just a geometric series where a is equal to 1 and r is equal to e to the x. So that we know that the sum is just a over 1 minus r. No biggie. And again, now it's only true if x is less than 0, because x needs to be negative, because we need that thing in the denominator, because we need that thing to be less than 1. Okay, here I didn't assume any of these answers. I just looked at what would happen if t squared over b squared was our r value. So it's a over 1 minus r. And I got this as my answer, but I was like, wait a second, that's not what I want, right? I need there to be a plus sign here. Well, if that's going to be a plus sign, then that had to be a plus sign, which means my r value needed to be negative. Bingo, negative. And then I don't have this b squared there, so then in front I must have had a negative, or a 1 over b squared in front. So the 1 over b squared cancels with that b squared, and the negative would make that a positive, and then bingo, I got what they want. Okay. X and y are positive real numbers. So if they're both positive, then all I really care about is that this exponential is less than 1. So I just need y squared to be bigger than x. Bingo. Okay. So I have this function, a to the n, and I know it goes to 3 with the ratio test. Well, if it goes to 3, this is going to go to 5, and that's going to give me 3/5. So that's actually going to converge. The ratio test is going to make that not matter, so it'll still go to 3. That just goes to 3. And that's 3 squared over 5, so that's 9/5, right? This one here makes it go to 3/5, which is less than 1. So by the ratio test, it converges. Another geometric series, just be careful. This thing is really this thing. This thing has an a value of this and an r value of this. And when you do the algebra, you get that answer. Just be careful that you actually find a and r. Remember, a is always the first term, and then r is the multiplier. This is a geometric series where a is 3/2 and r is 3/8. Go ahead and do this. The sum is a over 1 minus r and get your answer. I know I went kind of fast, but I just wanted to give you a couple hints on all of these things. You should be able to do a variety of these. You should know all of the tests, right? Nth term test, ratio test, limit test, integral test, p-series test, alternating series test. You should understand conditional convergence versus absolute convergence. You should be able to check endpoints. You should be able to explain them. You should be able to run all the tests. You should be able to justify all the tests. And you should be able to quickly look at something and decide what is the test that should be applied. Don't spend time applying a ratio test to a bunch of polynomials. Probably should be p-series or a limit comparison or one of those. But hopefully this helps you out.